Yes. Yeah, I'm well prepared, as you can imagine. So, well, it's not the first time I gave this talk, so somehow I hope I can deliver it to some point. And, well, the title pretty much tells the story. It's a bit about what edge computing is and where edge AI, which some people talk about these days, introduction seminars, chances in Germany and whatever stuff, talking about it, where there's some kind of a substance and fun in research and substance maybe from a commercial perspective. So if you are Googling computing continuum, these are pretty much pictures you get. So obviously there is something out there. Quick poll, who of you use the computing continuum, edge cloud continuum, something like that in the papers recently? At least some. So there seems to be something out there that is talking about, you know, the little stuff and somewhat the big stuff, so somewhere in the back ends, and typically you have, well, something like a continuum, and the question now is, how does this whole thing look like? So is there anything missing? I guess cloud computing is pretty much all there. Visualizing our data, backing up into the cloud, pushing computing to there. So obviously there is something that has been established, and the edge part, if you're thinking about mobile devices, well, we all carry around mobile devices, microphones, whatever stuff. So obviously these things exist. And when it comes to the cloud, I guess this is, it's not like there's no research any longer required in doing things, but it's just an established business model with a technological infrastructure, enough software that runs the whole thing. So this is solid as a rock stuff. So this pretty much we know how to do it. We will improve it over time, and now with more energy demands, every email now gets a summary by some integrated AI and whatever stuff. So if there wasn't enough energy consumption in the world, we just added AI to the whole thing. But at the very end, this is pretty much what we know how to do. If we're looking at the other side of the continuum, so when we're talking about edge cloud continuum, we have the whole edge stuff. And actually, if you're looking at those 30 years, Mark Weiser's paper, The Computer of the 21st Century, was published in '91. So we're talking about 35 years from pretty much that vision. And if you're looking at the history of mobile computing, this goes back at least 30 years, if not much more. So longer than some of the people in this room, obviously. So obviously there should be also, or we might expect that there's some kind of a substance of things which are delivered to somehow an industrial creative standard of what kind of computing you can do there, how to program the whole stuff and the like. So there has been a lot of the basic technologies, starting from 802.11, whatever stuff, a lower protocol base and other stuff, but and pretty much core of what we do with the mobile devices, it's either stuff that's on the mobile device, or it's some kind of client-server interaction with kind of an infrastructure going back to something kind of cloud-based out there. There has been a lot of research in ubiquitous computing, pervasive computing with, you know, follow-me applications, some kind of distributed automatic configuration, integrating the stuff in the infrastructure which is around. And if you're looking what your mobile phone, this is a mobile phone, isn't it? Yeah, it's doing typically, you're either roaming or you're connected to the next hotspot. This is pretty much as much of integration of services around that we're doing these days. And then you're going off to your cloud. So there's nothing on the continuum which we're actually using there, even though there has been a lot of work on OSGI Genie. I typically in my lectures, I do some kind of software archaeology and talk about Genie and explain what it is. And people say, oh, that's amazing. I said, yeah, it was a product integrated in printers from Hewlett-Packard, and people bought the printer, but nobody used Genie. So it's excellent technology, which we forgot how to do. So from a scientific perspective, cool stuff still there, many solutions there. From a commercial view, we're just shipping cloud services to the mobile device. That's it. So all the mobility is just more like a wireless line to the cloud, and this is pretty much what we have there. And so at the variant, the question now is, what's missing if we are really thinking about building something like an edge cloud continuum at that point? Under the assumption that it's a cool thing to have this edge cloud continuum, which at least some people raise their hands and are using in their papers and saying, oh, this would be a nice thing to have or to provide somewhat in the whole thing. And when we're looking at the different application models we can think of and how to cater it, how to use these edge cloud continuums, actually it's completely separated. On the left-hand side, we have what I would like to call more a cloud-based model. So what we actually have here is a multi-tier application. We have something that has some parts, stable, persistent parts in the cloud, but as more you're going to the edge, to the mobile devices, there is more kind of dynamism there, there's data that is generated, and actually the characteristics of the data. So the latency determines the quality, so if you have sensories and stuff like that, so you try to put the processing pipelines accordingly to the requirements that you have. Application domains would be something like, smart factories, so there's a That's actually also pretty hard to read from this distance, so pretty much it should be harder even for you. So this is just a picture of a smart factory at the University of Stuttgart. And so the question there is how to place part of the computation of the processing between where things happen, so where you have the sensors, where you have the actuators, and on which part of the spectrum you just cut your tiers, similar to a regular multi-tier architecture, but now with the knowledge about network latencies and where to place the computation. And this is pretty much done. Industrial stuff, if you're deploying modern industrial plant stuff, they talk about where to deploy these things. This is just engineered in this way. So from a business perspective, this is first cool, needed, and from a technical perspective, pretty much solved. People don't talk too much about it, which is kind of a pity, but frankly it's also not too exciting because there's not that much of dynamism in there, so all the stuff we are selling is cool kid on the block, so what we can do in distributed systems, it's more like engineered to work. And now on the other hand, there's this mobile edge computing, which also has been a buzzword around a bit, so with the idea to cater to the needs of mobile users. So you're walking around and you integrate the software of the things around. So stuff like being services that provide information about your vicinity, well, you can do it, but go to the cloud. Here the idea could be utilizing things really in some kind of a peer-to-peer setting from the devices next to each other to have latency-aware applications. So one of the things which are really starting to work now are Hitchhiker's Guide to the Galaxy. I guess still people read this these days when they're somewhat close to computer science fields. They tend to place this little fish in your ear, and the fish lives from your neurosignals, and in order to do that, it provides a service, which means it just translates arbitrary languages in what you understand. Nice. And now there are those earables. So there's one project at Tackle at Karlsruhe. Cecilia Mascolo from Cambridge is working on that. So you have small mobile devices in your ear running small trained AI models, and by that, out of a sudden, you can use these devices if you have a bit more computing power close by in the latency to provide simultaneous translation stuff like that. And there's, well, this is a number, 20 milliseconds. What do these 20 milliseconds give us? Remember in the old days when you had these multimedia lectures, lip synchronization. And often this is pretty much the time where you can cheat on humans, where humans wouldn't perceive that there's anything happening. So if you're quickly changing, the pearl under some kind of cups, you can cheat where things are. So everything you do below 20 milliseconds is something where the user wouldn't be disturbed, annoyed, whatever, or you could cheat on the user. And so now the question is, are there some nice application things we could deliver, push close to those 20 milliseconds end-to-end latency, including what you're doing, in order to provide services to the users. And then you can think of, if I was walking around and my phone or my new classes would determine, like, if you're walking into a conference and you see a person say, we've met. But who the hell is that guy? And then you see just, people going up and saying, oh, this is Christian from Stuttgart. was that person, he drags you to the bar, and some kind of annotation that might help you with that. And obviously, this is cool stuff. If you then think how to distribute the whole computing across devices nearby, and all the things people love to do in the early 2000s when it came to pervasive ubiquitous computing, you're back again. And so now the idea is having your personalized models. Obviously, you cannot put them on your earable or your classes, but if they follow you from access network to access network, you have some kind of a small cloud. There are mini clouds which cater the needs. You can have these in end-to-end latencies smaller, those 20 milliseconds. What a cool world. Obviously, this is the sex appeal when it comes to the research stuff. I'm not pretty sure whether this will ever hit the road and there will be more than maybe some generic services like for activity recognition that you might integrate in other applications, or assisted driving that you might offload part of this as kind of generic services. But besides of that, I'm not sure this will hit the road this time, because this is pretty much the same story the mobile computing people are trying to sell academically since 30 years, which is still okay because it's still cool research. Trust me, I'll talk about some of the aspects later on, but I don't want to raise expectations that there will be too much business cases in there. But first time I saw the World Wide Web in 1993, I laughed at it and said, what a crap. And it had some success. So now the question is, what are we talking about and the things we have here? The one thing is, how can we make this computing and services accessible? So from pushing cloud to the mobile, but also from the mobile to the cloud. But I think still this edge stuff integrates mobile to mobile, some kind of peer-to-peer communication among the devices where we spontaneously interact, connect, and make a better use of the resources that are around. And then we encounter different situations with these dynamisms. So the classical, if you're thinking cloud-based, deploy service or you start a service, it has with your computer, you start it, eventually it should be finished, right? This is our error model when it comes to computation. When we think about communication, we're pretty happy accepting that networking service typically our best effort. So if you want more than just a lucky punch, you have to add some layer 4 quality of service mechanisms, retries, whatever sequence numbers, you know all the protocols from your networking lectures, in order to make things more reliable. So you accept a higher cost and more mechanisms in order to make things nicer. For computation, it's a bit different, but if we're looking at computation and what devices are then providing, then we're facing a different situation. In contrast to cloud or your local computer that you have at hand there, if you're using remote services based on these little devices, we have battery trains. We can have expired cloud leases, which is also some nice effects. We still have loss of connectivity, even if people don't believe that there's something like non-network areas around. Because in Germany, we have a set, or it's a catastrophe of parts which are delivering crappy or no 5G or 4G connectivity even. Now the question is, how can we incorporate this specific dynamic behavior, not considering this an error, but just it's different. It's anticipated behavior. It is there, so it shouldn't be handled as an error, but treated as a side effect that we have to compensate for. And then also to think about how to support platforms from generic things like your mobile phone over to specialized things like the earables and stuff. And at the very end, still the question is where to place the computation, the services, how to build form distributed application from the whole thing. And here actually we find a different situation to cloud computing. So the solution of cloud computing, what cloud computing actually did was answer the question of the promise of grid computing. Grid computing was trying to integrate heterogeneous excess capacity platforms. Never really hit the road. Cloud computing worked. Why? Because it was homogeneous. We had one provider, one data center, shifting or selling virtual machines on pretty much the same homogeneous hardware. This is a less complex problem, and we have good solutions for it. But here we still have very high heterogeneity. We're completely decentralized. There is no central administration governance. It's your stuff, my stuff, that wants to integrate, hopefully, in order to do something nice. And how to somewhat handle is kind of a good question. So at the very end, it all boils down to what's the right plug, the right abstraction in order to make these somewhat usable in a nice and easy way. If we're looking at computation, one of the things is the granularity, so the abstraction that we have, and metering. That's one of the bigger flaws if you start providing something without making some kind of accounting enterprise to that. You cannot do quality of service management if you do not differentiate between the qualities, also with terms of cost. Otherwise, why should people lower the things? Pretty much like what Melanie said, why should, or presented in her talk, why should I lower my degree of comfort? The neighbor can do it, and we had the discussion after that, what's the penalty if there are some free riders in the whole system, and how can we do things cooperatively at the very end, I guess. Some kind of distributed agreement protocols are required, or negotiation protocols in order to do so. And the same holds true to also the technical aspect that we are talking here. So we have to meter and make a cost to this. And if we're looking at traditional approaches that we have when it comes to modeling computation, locally you start a process. If you're born after 1990, you might consider threads as a nice abstraction. Remotely, we have something like services, and well, it's basically sending messages somewhere, looking like a local procedure in a nice way. And when we're thinking about infrastructure, so the cloud, we just virtualize things. We have virtual machines, send hypervisors, whatever. These days, people Docker everything and use Kubernetes in order to schedule. Still some people using Slurm, but basically it's pretty much the same thing. So you abstract from the whole thing, and there you are. And now the question is, what from these things can be used for providing our need for something that is decentralized and tries to make something like a homogeneous abstraction on top of a heterogeneous world. And this is the part where, after talking already too long, I start with some shameless self-promotion about stuff we did in the last 14, 15 years on edge computing. Actually, we can actually do a coffee break, and from that we continue after the coffee break. So your chance to run away and see the beach instead of coming back. But hope to see you all in 15 minutes after the coffee break. Das ist